Hello, everyone, and welcome to part two of March Webinar Week. We are so excited to have you join us for this edition. Excited to introduce you to our speaker for the evening, but first, a big welcome to all of those who are returning to us, all of those who are new to us. If you are new to us, we wanted to just make sure you knew all about SE Codes and know who we are as a platform. We are a free platform for South Carolina residents to gain coding skills with hopes of you building your toolkit in order to become job ready, build additional coding skills, or even as just a hobby or an interest. So we would love for you to learn more information about SE Codes. So feel free to drop down in the chat if you'd like more information on who we are, or also visit our website. So we like to host these webinar series monthly where we pick the brains of mentors in our program, which is an awesome addition to our program that learners on our platform are able to connect with. So these are people in our community who are experts in the field and share their time and talents and knowledge with our learners on our platform, but also with our greater community by sharing their interests and passions through Webinar Week. So this week we have a very special mentor for you all. His name is Mr. Drew Varner. Those of you who have been around here before have seen him before and know what a fantastic person he is and mentor he is as well. So to introduce you to him, for those who don't know, Drew has worked as a software engineer for the last 20 years. He specializes in functional programming languages like Erlang, Elixir, and ReasonML. Drew founded 9FX, which is a small software shop focused on software engineering and cybersecurity solutions for federal customers. So without further ado, I would like to introduce you to Mr. Drew Varner, who is presenting to us on The Road Less Traveled, and I'm going to let him dive in deeper to that title, but you're definitely in for a treat and some fun along the way. So thank you so much, Drew, for joining us, and take it away.
Thanks, Morgan. I appreciate you having me back. Excellent. Let me go ahead and get this show on the road. All right. Do we see an intro slide there, Morgan?
I see it.
Outstanding. Outstanding. Super. All right. In the words of Robert Frost, we're going to take a look at the road less traveled. Here's the different parts of what we're going to discuss here. First of all, we'll talk a little bit, introduce myself, and then talk about what is a low density language, right? That is, what is a language that, may not be necessarily widely adopted, uncommon, esoteric, or what have you, how do I categorize these languages, right? Or how do I determine that it's sort of the road less traveled, right? And then we'll talk about the different reasons why, right? Why you would look at looking at some of these choices, right? These less common choices out there, particularly given what might be their lack of adoption or popularity, what the benefits are, right? Both from your position as a developer, as well as employers, why employers look to them. And then finally, if I've made a convincing argument, and the question is now, how do I go down this path, right? How do I walk the road less traveled? We'll talk about how to sort of engage in these areas, and how do you go from, the normal path, and how do you go off the beaten path? And then we'll wrap it up. So Morgan gave you a quick introduction. If you haven't heard of, for example, Erlang or Scala or ReasonML, this is the right place, right? Being in the road less traveled. I participate in some either standards organizations or industry groups focused around languages. And so part of my interest in the road less traveled probably has a lot to do too in terms of sort of seeking out these technical communities, right? And it's not just that, right? It's not just a technical group, but it's the concept of community. And I think that's part of the attraction here with some of the less common languages or technologies out there. And so I think that kind of feeds my bias on this topic. And then obviously I like to serve, I like to participate actively in these groups, right? Whether it be in terms of regular attendance or working on some sort of work product of these groups. I find that engagement of being in a group of people who are focused on a certain technology or an application of technology interesting. And this is part of folks who are interested in that, right, would also maybe be interested in some of these less common languages out there, particularly as developers. My choice of languages are, the word exotic might come to mind. Very often when I'm having a discussion, even with other developers, quite frankly, they say, "Oh, what do you do?" I write in Erlang. I've never heard of that or what have you. And I find that not just with, for example, talking to my parents, who might not necessarily know, the language choices, but even in the broader developer community, end up in sort of the exotic world. Some people will call them hipster languages, right? But that's kind of where I feel at home. So as a group, right? Not only am I a developer, I'm also a founder of a company. And so we've sort of taken that path as well, right? There's not a lot of folks, for example, that provide services, for example, in spaces like Erlang. Elixir is becoming a lot more common, but Erlang and Rescript, very, very small communities, right? Even though Rescript, for example, as a language was founded by Facebook, or Erlang came out of Ericsson. Even though there's a lot of big companies, we'll talk about some of them out there. As a technical founder, right, it provides a lot more influence on the direction of a company, particularly as a software company. And so we not only do we do these languages for fun, we also do them for profit. So let's talk about a low density language, right? There's a low density language is one with lower adoption, is how I'm going to define it. And there's lots of studies out there, and there's lots of talks out there about what leads to adoption, right? And what are the barriers to entry out there for a language to gain popularity and adoption. One of them can certainly be difficulty, right? As you go through courses within the SC Codes catalog and curricula, you will definitely stumble across different languages with different syntax, right? And you'll also stumble across things not only as syntax, right, and complexity of language contribute to difficulty, but also tooling, right? Are there things out there to help make the language easier? For example, many integrated development environments and things like that provide us tools to make our developer experience easy. Another possible reason for limited adoption of a language may be it has a limited scope or applications, right? For example, it may be that your language is focused on statistical analysis, like in a language like R, for example, which is broadly used in the data science community, right? So outside of that world, you're very unlikely to use R to script your Excel spreadsheets, right? Or you're not going to write a web application in it necessarily. So some of these languages have an intentionally narrow scope or purpose, right? And for that reason, they may not be adopted broadly outside of those communities. Another obvious reason that a language might not have high adoption is because it may be new on the scene, right? There's timelines out there. You can go to Wikipedia, right, and find out what, there's new languages emerging all the time. Programming languages is a key area of computer science, right? And so there's always work into making older languages better or newer languages based on some combination of goals the actual language developer has. And one thing I see often in the literature talking about language adoption is the concept of the killer app, right? For example, if someone were to say the phrase to me, "I use Ruby," I would typically associate in my head, I use Ruby on Rails, right? Whereas that's a common, definitely a common, what I call the killer application in that space. In the area, there's other areas as well. For example, if someone worked with the language Golang, for example, I may assume that they work in the container world around, for example, Docker or Kubernetes or anything like that. So those are sort of some of the reasons why a language may have lower adoption, or maybe what I'm going to call a low density language in this talk. And so using those categories, we'll give some examples out there in the field where I like to do sort of, taxonomies or try to divide things up, right? So in the case of difficult languages, right, on the left side, for example, we have a lot of functional languages, right, that either have interesting syntax or inherently robust and mature type systems but they can provide sort of a barrier to entry. For example, to new developers, Haskell is born a lot out of academia, right, providing interesting features such as being a functional language, being a strongly typed language, right, being a lazy language, and some of these constructs, take a while to sink in, right, in terms of developing capabilities around it. And I think PureScript falls in that same area, right. Erlang, which is a language I use all the time. Modern languages tend to favor less and less having line endings, right? Well, Erlang, in its infinite wisdom, has 3 different line endings, just like sentences, right? It can end in a comma, a semicolon, or a period, right? Which is sort of unusual. Same thing with OCaml. OCaml's got a very robust type system, right? Which takes a lot of fighting and learning in the beginning to move past it as well, and sort of a syntax that some people find difficult. And it may be because of what's common to us. For example, in the case of coming from languages like JavaScript or Java, for example, they're C-style languages in terms of how their syntax. So they fall in the difficulty comes from our unfamiliarity. On the other hand, some languages have these narrow scopes for specific applications. R is very, very popular in the statistical analysis world. The LabVIEW from Native Instruments is used to manage sort of gathering and analyzing data from their scientific instruments. Julia is very popular in scientific computing as well. And then Prolog came out a long time ago, sort of in the artificial intelligence and inference space, right? Before the most recent, I would say, burst of interest in machine learning and AI. And then there's also these languages that are kind of new on the scene, right? Which I've got in the far right column, right? A language like Gleam, which has been around for a few years. Dart, which came out of Google. Rust came out of Mozilla, sort of a focus on a strong type system, as well as having, some of the performance of languages like C, as well as having safety plus speed, right? And then NIM is a functional programming language new on the scene. So here's some examples of languages that kind of fall into those categories, right? I haven't looked at any who don't necessarily have the killer app, which is the 4th category, but these are sort of a breakdown of the 3. And for a language to be sort of hipster or, specialized, what I call this low density language, right? The road less traveled. The languages that have a big flux of influence now may have been written before languages you use, right? It's not necessarily a matter of timing. For example, Lisp, which modern languages like Clojure descend from, came about before most programming languages people knew today. But there's been certainly with a renewed interest in functional programming in the last few years, when maybe even the last decade, that Lisp has kind of regain some stature, right? Erlang, which is very popular in the concurrency focused world, right? If you're companies like your WhatsApps, for example, that manage, the largest chat applications on earth are powered by Erlang because it is a fantastic choice for reliability and concurrency, right? It sort of has that sort of special focus area, and that's its primary driver. Whereas also on the flip side, Reason, which came out from the Facebook crew out in 2016, is an example of a more recent language with specialized adoption. And I'd encourage you to check out there's a Wikipedia page on the timeline of programming languages. And it's an interesting read, right, to see what some of these languages you use and what languages came out around the time you were born, or the language I'm using now, how long has it been around for? See, somehow I copied this. Copy. Oh, there we go. That's the slide I wanted to copy. So this is my list slide. For those of us who aren't particularly nerdy to get the joke, Lisp is an unusual language in that it uses parentheses a lot. And so that kind of gives you the chuckle behind this comic from XKCD. Right. In addition to sort of an ontology or categorization of these languages in terms of, why they may not have been adopted recently, right? Whether it be recent release or whether it might be difficult to learn. It's also to break down these sort of languages in this space in terms of where you can apply them, right? Because, for example, if you're a web developer, right, you may not necessarily be interested in a language such as, let's say, a common Lisp, right? However, if you're used to the JavaScript runtime, its cousin ClojureScript runs within the browser, right? And so it's nice to know that depending on the ecosystem in which you work, right, whether it be native development, embedded, right, a lot of people run inside of either the Microsoft .NET runtime or the Java virtual machine. You still have these language choices there, right? There's still these areas for you to explore without you having to leave your comfort zone. And another nice possibility is ability to sort of interoperability, right? Foreign function interfaces. So I might be able to call, for example, my Scala code, for example, if I'm writing on the Java virtual machine, it gives me a functional programming language if I haven't worked in that space before. It gives me nice features such as, a robust type system, right? An ML-like type system and type classes, while allowing me to access the Java ecosystem of libraries that I may be comfortable with, right? So I might be able to reuse existing code there and operate in the environment that I'm in, right? And that matters, particularly if you're within a company or if you have an existing code base or an environment where you feel comfortable. There's almost always an option, right, to sort of experiment with one of these languages in the environment or in the runtime area, sort of where you feel comfortable. So now that we kind of know what's out there, so the question is, all right, there's a lot of languages out there that are not as common, right? The company down the street from me probably isn't using it to write their software. Why would I want to learn this software? Part of it is it's sort of an in and of itself, right? And that is I get to go learn something new, right? It's a good mental exercise, right? It's might be something fun to do in the evenings or for a weekend project, right? That's how a lot of people end up sort of diving into these languages, right? Hey, I want to learn language X. Let me go implement some project or some toy application I was thinking about doing. For example, I was in a discussion group recently and somebody was going to develop permutations of different names, to come up with possible names for their child or something like that. And it was some sort of toy little application to learn by doing, right? And those sorts of exercises can be fun, right? To learn something new. But another great possibility here is to not just learn something new, but something new that offers a different way of thinking. So if you look at the curriculum, the library of courses available primarily, for example, in the SE codes community with languages like Java, JavaScript, and Ruby, right? You see a strong focus on object-oriented programming languages. And those are great languages, and there's a lot of neat things you can do in the object-oriented world. But it's not the only way of doing things, right? There's definitely different types of programming languages out there that operate sort of in some ways similar, but some ways inherently different ways and require a different way of thinking. Some languages, for example, like C or Go, are largely procedural languages, right? They don't necessarily have the concepts you have in object-oriented languages of inheritance, right? And those are important differences, and we solve things in different ways. Functional programming languages, right, which instead of coming from the world of Turing machines, come from the concept of lambda calculus. And functional programming languages, right, we focus more on recursion, right, as a method to do iteration and stuff like that than what you'd think of in a conventional for loop within either a procedural or object-oriented programming language. So it's nice to have these different ways of thinking, and these different ways of thinking provide different benefits along the way. For example, in the functional programming world, right, we have a model of functional decomposition, right, whereas you may use a different technique in procedural like modular. And then finally, there's static versus dynamic typing, right? It's interesting to do both. For example, Python is sort of a dynamically typed language. I believe they're coming out with annotations to support sort of more typing along the way. And you see some of this now across the spectrum. The earlier slide I had, which kind of showed the breakdown of languages for different ecosystems, right? You'll look, for example, that if you look in the JavaScript ecosystem, you have different options for typing, right? And type safety, provides you some sort of guarantees at compile time versus runtime on where your code's going to break, right? Would you rather it break while you're developing it, or would you rather wait till it's deployed on your website to figure that out? And there's obvious things we can do like testing to do that, to sort of offset that risk or mitigate it. But, static typing, right? So in the JavaScript world, you have incremental static typing available through things like Typescript, right? And then you have some languages that come from the functional world that have different sorts of type systems, right? With things like Rescript, Elm, or PureScript. So they give you a new way of looking at the same problem, right? And it's nice to see what else is out there. I spent most of my career, for the first 10 years of my career, working in Java primarily, with some Python here, or a language like Groovy, which was a less common language on the Erlang virtual machine back in the day, right? So I've written in different languages, but I spent most of my life in Java, right? So it was refreshing for me to take a look at other language paradigms, right, to determine, that's a neat way of thinking about it. And one of the things I love the most, the final thing here, is community, right? It's sort of the we feeling we get from that group of people who shares either an interest or a passion, right, around this approach to software, right? It's one thing, I can't tell you how much I enjoy that in some of these smaller programming language groups. Really neat people, right, that you get to work with and discuss things with, sometimes argue over technical details on, but still, that's I don't know, this is necessarily depending on your reasons, community can be a very, very fun and great reason to sort of investigate these less common paths. Sure. But it's not just the developers that make choices for language, right? At some point, right, we not only do we want to be developers, at some point we probably want to be employees, right? It's fun to have a passion project at home or on the weekends, but a lot of developers either aspire or currently work in 9 to 5 writing code, right? And so if we're interested in these communities of languages with less popular adoption, right, somebody's adopting them, hopefully, right, and will pay us to do so. So why might that be? And I think in these languages, one of the most common reasons I stumble across for why do employers choose low density languages, they've made a determination that it's the right tool for the job, right? For example, we'll give you some example from the financial tech industry, or fintech, right? And one of the big things I've seen in discussions about using particular languages in that area is they have a lot on the line, right? They're not creating, a application to, update your shopping cart or what have you. They're making massive trades, for example, at high speed, right? Something like called high frequency trading, for example, or they're trying to analyze a market like derivatives to make decisions that generate or lose a lot of money. And they have to having the best tool or the right tool for the job provides them a competitive advantage. And employers are interested in competitive advantage to move forward and, be good at what they do and ultimately to make money. Another good example for this is concurrency. And I harp on concurrency because this is the community that I come from, right? This is particularly on the Erlang side of the house. Not your only option there, right? Golang is another great example of a tool people use in the concurrency market. But if you look at the big players, for example, in the chat market or in networking, a lot of them use Erlang. It is just like we talked about, Rails being sort of the killer application on the Ruby side of the house. I think chat servers like eJabberty and stuff like that, which are open source XMPP chat servers, were some of the killer applications on the Erlang side, right? Sure, the answer is we can always scale out, right? As cloud deployments become more popular, people can always scale out, but you pay for every second of computational time that you use, and it's expensive. So things that can handle a lot of tasks at the same time, right, that can handle concurrency, are the right tool for the right jobs in those spaces. And the other thing employers have to do, right, because you're taking a risk. For example, if I use a language that's less common, that means there's less developers available for me to hire, right? And so I think part of what employers in this space, why do they adopt a low density language? They may recognize that the skills I have today don't necessarily limit what I can do tomorrow, right? I may be inherently a developer, right? And I may have started out learning language X, but there's no reason I can't learn language Y tomorrow and thrive in that environment, right? And so the ability to develop their workforce and to find folks who are interested in learning these technologies, I think that's something a lot of employers have in this space, particularly as a low density language gains traction for a particular application, or the companies who use them grow. They have to be innovative, not just in their choice of language, but how they find folks in that smaller talent pool. And the final thing is, and I've read articles about this a long time ago from the company behind CouchDB, about the type of folks who kind of strike out their own path and go down this road less traveled are developers who are inherently passionate about what they're doing and interesting. And I'm not saying you can't be passionate in a mainstream language. You most certainly can, right? But to strike out on your own, if you live and breathe, for example, the language NIM or whatever else, it shows something about how much interest you have in that space, even if that's not what your developers do. Even if that's not what your employer does. I've met a lot of people, for example, in some of these communities who write code in their favorite language at night, right? Even though they may be using a different language during the day. And so talking about the strengths, right? The examples of concurrency versus type safety, right? And why might be interested in these languages. These are some sort of less widely adopted languages that meet those two criteria. And there are employers who certainly make this choice, right, about adopting one of these languages, right, because they have type safety, right, and the safety of their code is what's critically important to them, right, versus some folks are focused on concurrency. And so based on that, with my financial technology example here's some less common languages adopted by strong companies, for example, in this field, right? And I find that the financial technology field, they'll do whatever it has to take in order to adopt a language that serves their needs for competitive advantage. And I feel like in this space, folks are a lot less constrained from making these choices, which some others might be considered risky, because of the advantages they need over the competitors and how much money is at stake. For example, a company like Jane Street, right, they're trading their own money. And OCaml provides them speed and safety that they're not doing something wrong, right, through the NL type system, right, the Hindley-Milner type system. So if something goes wrong for them, they should be terrified, right? Klarna at the top is they're basically do when you're a large startup, and they make a lot of decisions, sort of like in a firm type deal. They started out in Europe, but they're getting a lot of traction in the United States on being able to sort of finance something you see online. You might not necessarily have the money for it now, but hey, let me finance on it, and I can click on it on the side. The ability to make a lot of decisions from a lot of different sources quickly requires the concurrency they get from the Erlang background. BlockFi recently just got a funding round, and their language is Elixir. If you heard David's talk the other day, that it's same thing, right? It runs on this highly concurrent runtime, same one as Erlang, and that's important. Standard Charter has a very specialized version of Haskell they use for some of their analysis, right? Because again, they need the safety benefits they get from that language sort of outweigh the fact that it might not necessarily be in the mainstream, right? And these companies aren't poor. A lot of these companies who are making these decisions aren't poor. I always found this out to be a source of anxiety for me at first when I pivoted from working within a mainstream language where I knew I will probably never get a job in South Carolina doing this, to realizing that I don't know that that's necessarily a problem. And these days, with the ability to work remote, especially during and post COVID, these firms can afford to hire employees as well, right? They're not holding bake sales, for example, to figure out if they're going to be able to make their next hire. They're doing well enough in high value markets that their decisions were considered worthwhile. So we've got the why for developers, right? Why might I look at some of these languages? Then we've got the why some of the employers, right? Assuming that it is perfectly legitimate, by the way, to say, I'm going to stick around and do my day job, and I'm going to write C# for this company that I worked for 20 years, and maybe I'll use a different language to expose myself to a new way of thinking, and it might make me a better programmer in the other language I use anyway. But but we also understand the why of employers, right? So there is a market out there for folks within some of these specialized languages. So now the question is, because this is something I had to do myself, right? I started out, graduated from the university, worked in the Java world for 10 years. How do you make the transition, right? And for me, it's not only just how do you make the transition to a language, I'm also going to talk some about how do you transition to a community, right? Like most programming languages these days, really almost all the languages that I've talked about or focused on come from the open source community. For example, from the very tools that run the code to compile it, right, to analyzing the tokens of the tools, almost all of them are out there within the open source community. So either on GitHub, and that's me on GitHub, Varner, or GitLab, right? There's opportunities to go out there and see what's happening in the community. You can see not only the code, how it's changed over time, right? These tools provide you the concepts of issues, right? And typically you go out there, you'll find links to documentation and what have you. So that's kind of one inherent element of the community, but it might be the least important in some ways, right? Because these tools that keep the source code, right, they can show you what happened, but it's not the community. There's certainly a lot of discussion, right, particularly on pull requests and stuff, or inside of issue trackers that occurs here, and it's worth getting sort of a feel for that community. But it's also very common in these communities to have some sort of way for interactive communication, and that's almost always chat. IRC, Internet Relay Chat, which I haven't listed here, used to be the predominant method, I would see, but lately, in recent years, I feel like Slack and Discord have taken up a lot of the market share in terms of interactive chat platforms for these communities, right? For the open source community in general, but also for some of these low density language communities that we've been talking about. And it's nice to be able to sort of have a discussion, right? Just like in the SC Code Slack channel, there may be different topics, right? For someone who's interested in a particular application of a language, or for the folks who are the core maintainers, right? Depending on the size. I'm in a community called Gleam, where, for example, it's a small group of people, and it's interesting to watch those areas grow. The downside I find to the chat method of interacting in the community is the people, because it's generally a worldwide community, right? Spanning, continents of who might be working on this project, right? What's one of the fun things about it? Somebody who might know the answer might not be on at the same time you are. And they're typically very difficult to search, right? That's the downside of the chat communities. I have a question, and that's what forums are for, right? There's some languages like the Rescript community we're in, and we actually have a product developed in Rescript. But in this community, they don't use an official Slack channel because of its temporary nature and how difficult it is to search. And they want the answers to be out there and to be searchable. And so forums are another way sort of to communicate. And a lot of these languages aren't just neat languages. They're good people and great communities. Now, that's not always the case, right? I've been fortunate with the groups in which I've been members of. They're very neat people, inclusive, helpful, and that's always something you look for. One thing you can look for very often in an open source project, for example, is a code of conduct, right? In terms of how we should behave as we participate in this community. It can sort of give you a good sign of the direction. Another thing I find that's funny is that I'll attend software conferences, and very often I don't know developers by name. I only know them by their GitHub username, for example, because that's sort of how we see them. And so it's interesting how much of the community happens sort of in the online fashion, how weird it is once it goes face to face. And I'm looking forward to face to face again soon. Right. But it's still a lot, right? Just because the source code and the issue trackers and all the stuff for projects available out there, there's, or just because there's a place you can communicate, right? How? What is sort of the concrete way to say, I think this is interesting. I'd like to get involved with it. And I like to use sort of the crawl, walk, run analogy here that, the first thing is just sort of get out there, right? Um, Very often when you join a new chat service, say, hey, my name's Drew, and I think this language is neat, and I would like to use it to do X, or I just want to learn more about it, or hey, I'm just here to listen. But and good communities will sort of say hello back, particularly in smaller communities as well. And then the next thing I did is read about it, right? There's plenty of materials online. Maybe you get a book, but blog articles, read and watch and sort of learn about the community you're in or the technology and figure out, is this for me, right? And people will talk about it, right? Watch the discussions on the different forums, whether it be a forum or a chat group or whatever else, to see, what people are using it and what their problems are. Because very often I found out that diligent maintainers are particularly interested in the issues and the problems that newcomers face, right? Because good communities want to remove barriers for adoption. And then work through a tutorial, right? Figure out and say hello world in your language, right? Or do some of the sort of the introductory level things. For example, I'm sure we do similar stuff in the SC Codes curricula in terms of getting up and started, right? And that sort of gives you the initial confidence for I'm here. And then once you sort of gain some sort of confidence and familiarity with, whatever this new technology is, make something, right? Something small, either a weekend project, something for your employer, proof of concept, right? Learning by doing is sort of the next step, right? And it's really the beginning of the walking phase in terms of programming. And there's contributions you can make in these communities beyond strictly writing code. Writing documentation is extremely valuable in making a community accessible. And if you can document something, people will be grateful. And then you can work to fix something that's broken, right? If it's broken for someone else, or even if it's broken for you, go out there, fix an issue or add a feature. That's one of the nice advantages of sort of this open source community. If there's something that you'd like to make better, you can. A very common expression I hear in chat groups when somebody says, I'd like to have X, depending on people's bandwidth, they may say, pull requests are welcome, which means you're welcome to add that feature or fix that. And so that's when you start to get up to speed, and that's sort of walking briskly in these communities, right? In any technical community, but particularly around low density languages. And when you're off and running, it's a good time to sort of give back and help others, right? This could be answering a question. Someone may have some sort of issues. It could be answering a question on one of these things, chat, forums, what have you. Go attend a conference if you got a chance, whether it be virtual or in person. And we have an expression, we talk about hallway sessions. So conferences have different sessions, right? Somebody might be talking about DevOps over here, and somebody might be talking about, performance improvements or whatever this thing is. But the hallway session, right, is people getting together in the hallway and socializing and talking about what they're doing, right? This is the informal interaction that comes about from conferences that I find a lot of fun. And we're lucky with folks like having things like Open Source 101 to have some neat conferences in this area, right? That you can have that sort of engagement. And then blog about what you're doing, right? Go out there on Medium or give a talk, right? What I've found to be in a lot of these communities is there's plenty of people that are experts, but the experts in the end up being the person who gives the talk, right? Partially by virtue of the fact that they gave the talk. It's a self-licking ice cream cone in that respect. And so in a more concrete, right, we're not just talking to anybody here, right? I mean, I would assume that, some of the folks who are listening to this talk actually, participate in the SC Codes community. And SC Codes has a library of courses available, right, of different levels of learners, right, to sort of bring folks into this world. I often equate jumping into a new programming language like cooking, right? One of the most important things about being a cook is not necessarily knowing how to cook, but realizing that you can cook, right? That's sort of that confidence and those building blocks to be able to learn something new. And I find that to be definitely the case as well in programming, right? In the end, even though there may be different ways of doing things, such as object-oriented or functional, we're doing some of the basic same things, right? We have conditional logics, right? If so-and-so happens, do this. Otherwise, go this way. Or we're doing some sort of operations. We're adding or subtracting. We're doing input and output. And the basics are the basics, right? And so I feel like there's jumping off points between the curricula SC Codes provides now into, I feel confident in after having taken the JavaScript concepts, right? And I'd like to go take a look at something else, right? So on the left-hand side, I've got some different languages which either take different philosophical approach, like functional programming, such as Rescript and PureScript, or one that just goes from more dynamic to incremental and static typing, something like TypeScript, right? And TypeScript is hard to call a low density language. It has been widely adopted, I feel like, because I feel like there's been a big push in the JavaScript community. As JavaScript programs become more complex, the type systems can kind of help alleviate some of those pain points. And so those are sort of your jumping off, maybe a jumping off point if you've gone through the JavaScript concepts course. The Java concepts course, right? Because Java typically tends to run on one, back-end systems, whether it be web applications or what have you. I feel like it's a great place to go jump into something like the Rust programming language or OCaml, right? Because you're already comfortable with static typing at the point where you're in the Java world, right? And so, these are different languages. Say, I like to see how folks use a different type system or how a different functional paradigm like OCaml, how that applies. And that's a jumping off point there. In the Ruby world, when I hear Ruby, I implicitly hear on Rails, right? Web applications, what we call a lot of full stack devs or whatever else. Elixir and Dart might be good examples. You see a lot of, when I see the Elixir world, which has the Phoenix application, I don't know if y'all saw, there's a fantastic talk on it 2 days ago. But in the Elixir world, Phoenix is the killer application, right? Phoenix and Ecto, which is sort of, it's not a one-to-one comparison, but think of it as Ruby on Rails for Elixir. It's a natural jumping off point to go from Ruby into something like Elixir, or maybe you want to look at mobile and look at a new language like Dart, right? So if you're looking for jumping off points, right, if you've been through the SC Codes path here and you're looking for a jumping off point, these might be natural progressions, right? But the correct answer is do whatever you like, right? I mean, if there's something you want to go explore or read about or learn about, it's not a wrong answer. And so, I forgot a conclusion slide. Well, in conclusion, I'm Drew. Varner is my GitHub name. You'll find me lurking, in addition to lurking around SC Codes as a mentor. You'll also find me around other groups like the Cola Tech group locally. I even lurk in the Charleston one. You'll find me, if you ever go explore some of these communities, you'll find me in the Elixir Slack or in the Erlang Slack channel. Sometimes I'll very often go to Erlang conferences. You can find me with the open source meetup that Todd runs. So you can find me here locally in the community, and I appreciate you having me.
Thank you so much, Drew, for that awesome presentation and that awesome information. I would definitely encourage everyone on our platform, if you have more questions, to follow up with Drew, who's definitely an expert. It talks a lot. It was definitely an expert in this content and has a ton of information to share across various topics as well. So please take him up on that offer to connect with him. It looks like you have done such a great job that we don't have any questions out on the floor right now, but wanted to take time again, realizing that my camera is off. Hello, 2020. How many times have we said that? 2021. Wanted to take time again to thank you for closing out our webinar week with such great information, and also thank you for being a mentor in our program. And for those of you, again, who are thinking about possibly joining our platform, know that you have the opportunity to connect with people like Drew and so many others. So thank you again, and we hope to have you back here again very soon, possibly for April webinar week.
My pleasure, Morgan.
Thank you, everyone. Have a great evening.